In this video, we're going to do a review of scientific notation. Most of you will have seen scientific notation in your math class at some point, and so I just want to go over the idea of scientific notation. Scientific notation is used so that it'll allow us to write a very, very large number or a very, very small number in a more condensed format. For instance, let's say we have the number 403,000. 403,000 is the same thing as, if we were to write it in scientific notation, there would be a decimal right here, an invisible decimal right here. And what we're doing is we're going to be writing so if we have this number 403,000, what we can do is we can take that decimal point and move it back. We're going to move it 1, 2, 3, 4, 5 places. And what that allows me to do is condense the writing. I'm going to write 4.03, and then I'm going to put times 10 to the, and 1, 2, 3, 4, 5, to the 5th place. So 403,000 is equivalent to, or the same as, 4.03 times 10 to the 5th power. If we want to write it another way, we can write this as 4.03 capital E to the 5th. All three of these are exactly the same. This is the formation you will typically see in math class. This is the notation you will typically see in science. A capital E to the 5th is the same as a times 10 to the 5th, which is the same as 403,000. If I do another example, let's say I have 6,305,000. If I want to put this into scientific notation, the decimal, the invisible decimal, will be here, and we'll move it 1, 2, 3, 4, 5, 6. One point to make is we always leave one non-zero digit to the left of the decimal. So we moved it 1, 2, 3, 4, 5, 6. We didn't move it 7. We didn't move it 5. We move it 6, so that it's 6.305 times 10 to the 6th, because I moved the decimal place 6 places over. I can also write that as 6.305 e to the 6th power. Now we can also do this with very small numbers. Let's say that we have the number 0.000281. So this time the decimal is here, and I'm going to be moving it to the right. 1, 2, 3, 4 places. Remember, I'm only going to move it to where I have one non-zero digit to the left of the decimal. So we move it 1, 2, 3, 4 places. So this becomes 2.81 times 10 to the, but because I started with a small number, a number less than 1, I'm going to use a negative exponent. 1, 2, 3, 4 places to the negative 4th, which is the same as 2.81 e to the negative 4th. All three of these are the exact same. This is a condensed version. Even though it doesn't look like it necessarily, it's a condensed version, scientific notation. If I have 0.152 and I wanted to put this in scientific notation, I only need to move the decimal one place over. And you only move it one place so that one non-zero digit is to the left of the decimal. So we end up with 1.52 times 10 to the negative 1, because I had to move it over one place, which is the same as 1.52 e to the negative 1. All three of these mean exactly the same thing. We can also do the reverse. We can also take, let's say, 2.85 e to the 4th, and turn it into standard notation. What this means is that we're going to have or move the decimal place 4 places to the right. So this will be 1, 2, and then if I move it 2 more places, I'm going to have to add some zeros. 1, 2, 3, 4 places over. So this will be 2, 8, 5, and then I had to add 2 zeros, so it would be 28,500. 2.85 e to the fourth is the same as 28,500. Or if we had 6.97 e to the negative fifth, that means I'm going to move the decimal. The number I'm going to end up with is going to be less than 1 because it has a negative exponent. The negative exponent doesn't mean a negative number. It means it's going to be less than 1. So I'm going to move the decimal 1, 2, 3, 4, 5 places over. So I need to add zeros in. Now I can check that. 1, 2, 3, 4, 5 places over. So this is going to be 0.1, 2, 1, 2, 3, 4, 6, 9, 7. And that will give us our final answer. I hope this helps as a review for scientific notation, turning it from standard notation into scientific notation, as well as from scientific notation back into standard notation.